primitives. Okay, so like we have discussed authentication. So next, second service we have confidentiality. So here, what is mean by confidentiality? So in the networks, whenever we are transmitting the information from one node to the another node, or from one network to the another network, so the message should be kept secret. That is called confidentiality. So here, with help of cryptographic primitives, we can provide the confidentiality. Under security services like data integrity. So what is mean by data integrity? So here, whenever we are transmitting the message from source to the destination or sender to the receiver, the messages should not be read by attackers or third parties, as well as should not modify. So that provides data integrity. So then we have one more security service like access control. So here access control and authentication both are different. So authentication is nothing but the process of identifying the user. So here access control is nothing but, okay, so here each user will be having different access permissions in order to access the computing resources. That is access control. And we have one more security service like non-repudiation. Non-repudiation is nothing but, so which provides integrity as well as authentication. The sender cannot deny that. So how send the message? So that is the non-repudiation services. Okay, so here we have just discussed about the definitions. Now how to provide the crypto primitives. The how crypto primitives will provide these services that we need to discuss. Okay, so we'll go to the next slide. So you can see this. So now, if you want to provide the confidentiality services, okay, so how to provide the confidentiality? For this, we have crypto system. Okay, so like symmetric encryption system and asymmetric encryption system we have. So most of you have studied how symmetric encryption will works. Okay, so here you consider that. So this is the sender and the receiver. So there is a communication channel. This is insecure communication channel. Okay, so here what is mean by symmetric encryption? So here encryption is nothing but the process of converting the original text, or we can say that the plain text into the unreadable form. That is called encryption. Okay, so this encryption can be done at the sender side. Then the encrypted message is called ciphertext. The unreadable message is called ciphertext that will be transmitted across the network. So here, in order to encrypt as well as decrypt the message. Okay, so decryption is reverse process of encryption. So decryption is nothing but the process of converting unreadable messages into the normal form or plain text. That is called decryption. So here we need some mechanism. Okay, so that is called key. Okay, so in order to encrypt or decrypt the message, we need a key, secret key. Okay, so that is shared by third party entities in the symmetric encryption. So here, why it is called symmetric encryption? Okay, so here the encryption process and the decryption process. Okay, so based on the single key. So the key we are going to use for the encryption and the decryption, both are same. So that is symmetric encryption. Okay, so here what is the disadvantage in this key? So this is used to provide confidentiality to the messages. Whenever we are transmitting the messages, we are encrypting and transmitting across the network. Now, what is the disadvantage in using symmetric encryption? So here, the encryption and decryption keys are same. So if any one of the party, so like sender or receiver, will reveals the key, the entire security will be compromised. So that is one of the drawback. So most of the crypto algorithms make use of public key cryptography, or we can say that asymmetric cryptography. So here you can see that. So there is a slide how asymmetric cryptography will work. Okay. So now here we have a encryption and decryption processes like sender and receiver. How the asymmetric key cryptography will work. So here each party like sender and the receiver will be having a pair of keys. Okay, so a pair of keys is nothing but each user will be having one private key and public key. Okay, for encryption as well as decryption. Okay, so in this environment, how to encrypt the message? Okay, so in asymmetric, okay, or public key we can say. Okay, so the keys are different. The encryption key is different and decryption keys is different here. Okay, so now in encryption, okay, suppose the party A, sender A wants to send the message to the B. Okay, so how to perform the encryption in this scenario? Now, A will send some message. Okay, so the message is in plain text that will be converted into the cipher text. Okay, so in order to do the encryption, the sender will use public key of receiver. He will use the public key of the receiver and he will encrypt the message. After that, the messages will be transmitted across the communication channel. In the receiver end, he will be having private key and he will decrypt. Okay, so each there is a public key pair. Okay, so like a private key, public key, like that. Okay, so now sender will encrypt the message using B's public key, so that the B will decrypt the message using his private key. So like that, asymmetric cryptography will works. Okay, so next we need to understand the important thing like digital signature. So digital signature is widely used in blockchain technology. So let me explain how the digital signature will be happened. Okay, so here digital signature, which is used to provide the services like authentication as well as message integrity. We have discussed some security services. So like authentication and integrity will be provided with help of digital signature. Okay, so now how to generate the signature. Okay, here we have a sender A. After that, if you want to send a message, we can say that M, and the messages will be hashed. Okay, so here hash function. Hash is a function which takes variable length of input and which produces fixed output. That is called hashing. Okay, for a variable length of input, we'll get the fixed output, or we can say that digest. That is message digest. Okay, so once we got the message digest here, that will be encrypted using A's private key. Okay, so here we are going to use the public key cryptography. Each users will be having private key as well as public key. So here, in order to perform the digital signature, here party A will use is private key in order to encrypt the message digest. So we will get CIET digest. This is called digital signature. Okay, so again I will tell you. So if you want to transmit the message M, so we are taking the hash of that. Okay, so hash is, we have different hash algorithms. Okay, for this SHA-160, 256, MD5, so many algorithms are there. You can refer network security for this. Okay, so then here we will get message digest. After that, the message digest will be encrypted using A's private key. We will get the digital signature. So this is at the sender's side. Now here the actual message and the digital signature will be combined and transmitted across the channel. Okay, so here you can see that this is the digital signature. Here is the message. This will be transmitted to the destination. This algorithm is known as digital signature creation algorithm. Okay, so next slide, we have digital signature verification.
Shashi sir.
Yes, sir.
Sir, one small request.
Yes, sir.
Most of the participants are viewing from the mobile. So what they're asking is to view this PPT in full screen.
Yes, sir. Sure, sir. I'll make it.
Yes, sir. Thank you.
Yes, sir. Sure. Okay. So here digital signature verification we are discussing. Okay, so digital signature is generated. Now how the receiver will verify the signature. Okay, so here we have received the signature from A. You can see from A we have received the signature which consists of digital signature part as well as message part. Okay, so now what the receiver will do? Receiver will decrypt the digital signature using A's public key, because A will send the public to everyone to the network. The public key is public, private key is only to the particular user. Okay, so like with help of the public key of the A, the receiver will decrypt the message. So he will get message digest here. Okay, so now here the actual message will be hashed. So here also we'll get the message digest. Okay, so now here we have message digest here and here. We can compare both. Okay, so if any difference, so the message is altered, that is the conclusion. Otherwise, the signature is valid. So with help of digital signature, so even we can authenticate the particular sender as well as we can provide the integrity service. This is about digital signature. Okay, so then one more cryptographic primitive you need to understand, hash function. Okay, so hash function is like compression function. So you can give any length of input which produces fixed output. So based on based on the algorithm. It's based on the hash function. Okay, so here you can see that it will take variable length input and which produces the fixed output. Okay, so we will call hash functions as one-way hash functions. So because for a given message m, it is easy to compute h of m. That is, for a given message, we can easily compute hash function, hash value. Okay, for a given hash, it is highly impossible to compute the original message m. Okay, that's what we'll call hash functions, one-way hash functions. Okay, so now some other crypto primitives we're going to use in blockchain like cryptographic nonce and timestamp. So we can say that what is mean by nonce? The number only generated once, that is nonce. So nonce is nothing but it's a random number. Okay, so in cryptography we are going to use random number, that is nonce. Okay, next we have one more crypto primitive like timestamp. Okay, so what is the timestamp? So timestamps are used to record the time and date whenever you are performing some transaction in the blockchain network or any network. So we are going to capture the transaction date and time. Okay, so here that will be helpful in order to avoid the replay attacks in the network. So these are few crypto primitives. Now we will discuss more about blockchain. Actually, what is mean by blockchain? How blockchain will work? We will discuss now. Okay, so here we will define blockchain. So blockchain is a digital public ledger that records online transactions. Otherwise, we can say that blockchain is a decentralized network. Blockchain is a decentralized network which is used to ensure transparency and security. Otherwise, one more definition we can. So blockchain, so which is a chain of blocks. What blockchain can contain? So in blockchain, it consists of number of blocks. Each block will be having some information. Then each block will be connected with each other. Okay, so we are going to use previous hash. Let me demonstrate how the blockchain will looks like. Then you can easily understand. Now you try to understand what is meant by definition of the blockchain. So you need to tell blockchain is a decentralized network, so which is used to ensure transparency as well as security. Okay, so now other services. Blockchain ensures confidentiality, integrity, privacy by encrypting and validating the transactions. So here transactions means not only we are sending the cryptocurrencies, sending and receiving. So like other things like we can deploy the smart contracts. That is also transaction in the blockchain network. So here when a new block is added to a blockchain, so it is linked to the previous block using cryptographic hash generated from the contents of the previous block. So this I will explain how we are going to connect the previous hash. I will demonstrate one simple blockchain. Then this ensures the chain is never broken. So like with help of the previous hash in the blockchain, we cannot modify or we cannot immutable the records. We cannot modify the content of the block in a blockchain. So that is the sentence. It is also highly difficult to alter the transactions in the blockchain. So here all subsequent blocks will be altered if you are trying to modify. So that is the conclusion. Now you can see that what blockchain consists of. Okay, so blockchain, there may be a number of blocks. It will be connected with the previous hash. Okay, so now a blockchain system consists of transactions, decentralized peers, encryption processes, consensus mechanisms, optional smart contracts. So here transactions is nothing but whenever we are transmitting or transferring some cryptocurrencies, that is transaction. Otherwise, we are deploying the smart contracts in the blockchain network, that is also a transaction. And blockchain consists of decentralized peers. So decentralized peers is nothing but the independent nodes are the computers, so which can produce the services and which can consume the services. That is decentralized nodes, we can say. Then blockchain consists of encryption processes. For example, in order to hide the transaction, in order to provide the confidentiality to the transaction, the blockchain is going to be used some public key cryptographic algorithms like elliptic curve cryptography, and we are going to use digital signatures and hash functions, etc. Then the blockchain consists of consensus mechanisms. So what is mean by consensus mechanisms? So like if anything goes wrong in the blockchain technology or blockchain network, who will take care of that? So there is a consensus protocols. So consensus protocols is nothing but agreement between different blockchain nodes, that is called consensus protocols. So we will discuss more about the consensus protocols in the upcoming slides. And blockchain consists of smart contract. Okay, smart contract is nothing but it's like a computer protocol or a computer program. So we can write the program you can use the Solidity, Python or Go language, and we can deploy in the blockchain network. So that is smart contract. Like what functionality you need, like programming, we can write the smart contract. So the difference between normal programs and the smart contract, the smart contract will run in the blockchain network. Whenever we are deploying or invoking the smart contract, the transaction ID will be generated. So that is the difference between smart contract and the normal program. Okay, so let me demonstrate how the blockchain will looks like. So then you will understand. So you can see my screen. So you can look at the screen. Okay, so now we have discussed about the hash. Okay, so you can see that this is the data section. Okay, so how to generate the hash, how the hash value will looks like. For example, I'm giving some input, blockchain. You can see the hash value. Okay, so here whatever value, so it produces some fixed output. Okay, so this is hash value. Okay, for a given input we can produce the fixed message digest, that is hash value. So in the blockchain technology, the hash we are going to use is SHA 256, that is secure hash algorithm 256. This is about the hash, and I will show you simple block, how the block will looks like in the blockchain. So you can see my screen. Okay, so here is the simple block. Okay, so what simple block consists of? Okay, so this is a block in a blockchain. Okay, so it will be having a number that is called a block number. Then we have nonce. Okay, so here nonce is nothing but a random number that we don't know. Okay, so random number, the number only generated once, that is nonce. Okay, so here we have some here data section. In data section we are going to store the transactions. Okay, so now you can see that hash value. Okay, so this is the hash value for this entire block. Okay, so here we have a block number, nonce, and the data section. In the data section we are going to store the transactions. Transactions is nothing but, for example, you can take the Bitcoin transactions, from which parity to which parity we have sent the Bitcoins, and how many Bitcoins we have transferred, everything, that is transaction details will be stored in the data section. Now here hash value is nothing but the hash of entire block. So here see that hash value, if you are performing any transaction, the hash will be changed. Okay, so now here this is the hash value. Now I am performing some operations, I am typing something, you can see that the hash value will be changed. Okay, so again, if you want to take it to that particular target value, we need a mining. Okay, so mining in a blockchain. So I will tell you in the upcoming slides what is meant by blockchain mining. Okay, so this is a simple block in the blockchain. Okay, so now what is meant by blockchain? So now we have seen one block in a blockchain. Now here we have blockchain. You can see my screen. So here this is the blockchain. I have 5 blocks. Okay, so here block 1, block 2, block 3. Okay, you can see that. So here block number we have, nonce we have, data section, and one more field we have previous hash. Okay, so this is the chain. Okay, so now this is the first block of the blockchain. Okay, so the first block of the blockchain is known as Genesis block. Okay, so here the Genesis block is nothing but first block. Here the previous hash will be 0 because the blockchain is starting from here. Okay, so here we will consider previous hash as 0. Okay, so then this is the hash. This is the current hash of the block. Okay, so now you can see that. So if you want to change any value, you can see that other blocks also it's going to be changed like that. Why? Because now you can see the hash values will be changed everywhere. Okay, so now here previous hash, you can see the second block. Okay, so here previous hash. So this is the hash of first block. Okay, similarly you can see the previous hash of third block is second one. So like that. So if you are performing any operations, okay, so this hash value will get changed. So this is the blockchain. So here we cannot alter any transactions. If you are trying to modify one single transaction, so that will be get updated in all the subsequent blocks. So that modification is not possible in the blockchain network. Okay, so that you need to understand. Okay, so once we have added the transaction, okay, then we need a blockchain mining. So blockchain mining is nothing but the miner will be there. He will add a new blocks whenever we are performing the new transaction. That is called blockchain mining. I will explain you that. Now you try to understand how the blockchain will work. So this is the previous hash is the link. So this is the chain. The previous hash will behave such a chain in the blockchain. Discuss more about blockchain. Okay, so here we have a distributed blockchain. Here is not only single peer. So here the different nodes will be differentiated in different peers or nodes. So this is peer A, now peer B. So like that. This is a distributed blockchain. So now we have tokens. You can look into the slides. Okay, so now you can see the block. Now here this is the final hash of the current block. Now we have previous block as a 0 because this is genesis block. Now here we can contain the transaction information. You can see that transaction information will be there here. Okay, so now what is the Bitcoin or cryptocurrencies we have sent from where to where? So that will be recorded in the transaction section. So this is first part is called header of the blockchain. So here mining statistics will be having, and second thing is called body of the transaction. So body of the blockchain, here we are going to store the different transactions. So you can see that now you have to observe one value. So here the hash value will be starting with 4 zeros. Okay, so every block you can see that. So like that we need to set the random number. Once we have corrupted the block, so here we need to generate a nonce value. So this is the nonce value. Okay, so here we have to, if you want to change the nonce value, you can see that the hash value will be gets changed. Okay, so it's not starting from, it's not leading with 4 zeros. Okay, so now here we need to find a number such a way that it has to come 4 zeros here. So that is random. Okay, so here the miners will solve that solution in order to get the target value. So like this. Okay, so and one more we have like coin-based transaction. So here I will tell you what is mean by coin-based transaction. Okay, so here if the miner will solve say puzzle, cryptographic puzzle. So here what is mean by cryptographic puzzle? Okay, so every time we are performing some operations on the blockchain, so then there is a target value. So if any other new miner has to add a new block into the blockchain, he has to solve that cryptographic puzzle. Okay, for example, the miner has to get this value, hash value. Okay, so he has to find some nonce value. At what nonce he will get this, he don't know. So that is called mining. So after finding a solution for the cryptographic puzzle, the miner will get a reward in terms of Bitcoin in the Bitcoin network. So like this, the simple blockchain will work, and we will discuss more about the blockchain here. So we'll go back to the presentation. Now we can see, so what blockchain consists of, we have discussed. Now we will discuss about cryptocurrencies. Okay, so actually what is mean by cryptocurrency? Okay, so how it is differ from digital currencies. Okay, so that is the thing here. Okay, so we know that crypto means secret currency. Okay, so secret currencies, cryptocurrencies is nothing but secret currencies or digital currencies. So which is based on the internet medium of exchange, which uses cryptographical functions to conduct the financial transactions. Okay, so here cryptocurrencies, if you want to transfer the cryptocurrency from sender to the receiver, we should not require any intermediaries like wallets or a bank. Okay, so directly we can make a transaction from one party to the another party. So that is possible using cryptocurrencies. Okay, so now why the cryptocurrencies are so popular compared to the currencies? So that we will discuss. What are the properties of cryptocurrencies? So first of all, we need to know cryptocurrencies are digital. Okay, so it means cryptocurrency only exists on computers. Okay, so there is no notes like denominations or coins in the cryptocurrency. Next, cryptocurrency is decentralized. So this is not controlled by any banks. Say decentralized. Okay, so cryptocurrencies do not have any computer or a server. So they are distributed across the networks. So that is the decentralized networks. Now peer cryptocurrencies are peer to peer. The cryptocurrencies are passed from one person to another person online. So here users do not deal with each other through banks. Okay, so that is the peer to peer. And some other properties like cryptocurrencies are pseudo anonymous. So because of this, the bitcoins are very popular. Pseudo anonymous is nothing but the identity of the bitcoin users will not be revealed. So the users of the Bitcoin or cryptocurrencies are always anonymous and untraceable. Okay, so that is pseudo anonymous. This means that you don't have to give any personal information to purchase the cryptocurrency. So there are no rules about who can or use the cryptocurrencies. Anyone can use the cryptocurrencies. There is no restrictions. So then one more property, trustless. So here, no trusted third parties means that users do not have to trust the system for it work. So users are in complete control of their money. So that is trustless. Then the cryptocurrencies are encrypted, so which provides highly security and transparency that we have discussed. And cryptocurrencies are global. So here cryptocurrencies can send all over the world. Cryptocurrencies are the currencies without any border. So these are the features make cryptocurrencies very popular. Okay, so now one of the popular cryptocurrency is Bitcoin. Okay, so what is Bitcoin? Bitcoin is a cryptocurrency. It is a decentralized digital currency without any central bank that can be sent from one user to the another based on the peer-to-peer network. So here we do not need any third parties like banks. Okay, so the Bitcoin actually introduced in the year of 2009 by Satoshi Nakamoto. When the Bitcoin was introduced, the cost of one Bitcoin, it was almost 65 Indian rupees, 65 rupees. So now the cost of the Bitcoin is almost 5 lakhs something. So we came to know how the Bitcoin is popular. Okay, so the technology behind Bitcoin is blockchain. So there is no Bitcoin without blockchain and technology that we need to understand. So here, the transactions are verified by the network nodes through cryptography and recorded in a public distributed ledger called blockchain in the Bitcoin network. So now, Bitcoin is the world's largest cryptocurrency by market. Second is the Ethereum, or we can say that Ethers. Okay, so I'll go to the presentation mode again. Current slide. Okay, so now here we have Bitcoin anonymity. Okay, so we have discussed about anonymity. So anonymity is nothing but, so the user details will be remained secret. So we should, the network should not reveal the details are traceable. The users are untraceable in the Bitcoin network. So because Bitcoin is a permissionless. Okay, so here anybody can join into the Bitcoin network. So like anybody can purchase the Bitcoin, anybody can make the transaction. So that is permissionless network, or we can say that public blockchain network. Bitcoin is a public blockchain network or permissionless network. You do not need to set up any account or require any email address, username, password to log in into the wallet. So then the public and private keys do not need to be registered with the wallet. The Bitcoin, only the Bitcoin, if you want to transfer the cryptocurrency or Bitcoin, we are going to use the Bitcoin address of the receiver. So with the help of that, I will make the transaction how the Bitcoins will be transmitted from one wallet to the another wallet. Okay, so in the upcoming slide, I will show you. Okay, so here we are going to use Bitcoin addresses in order to send the money from one wallet to the another wallet. So here each person can have many such addresses, each with its own balance, and here difficult to know which person owns what account. Okay, so now we have discussed about Bitcoin. So now here is the cryptocurrencies. So not only the cryptocurrency like Bitcoin, there are 1,000 cryptocurrencies are exist in the world. So the things you need to know, the cryptocurrencies other than Bitcoin, the important cryptocurrencies like Ethereum, Ripple, Litecoin, Tether, Bitcoin Cash, Libra, Binance Cash. So these are other cryptocurrencies, popular cryptocurrencies other than Bitcoin. So the cost of the Ethereum or Ether will be 11,000 now. So now we will discuss more about blockchain. So not only the block number and nonce in the blockchain. So here you can see the slide. So here we will define what is meant by block. Okay, so here block is a bunch of transactions that have been added to the blockchain. So now we can see that block n plus 1, block n plus 2. So there are three nodes, blocks in the blockchain network. Okay, so now there are two parts. First part is blockchain header. Okay, so then here list of transactions, that is blockchain body. Okay, so now here in block header we have some fields. You can see that version, which version of the blockchain. So then Merkle root. So here Merkle root is nothing but, so we are going to store a transactions in a blockchain. So the hash of all the transaction. Okay, so if you have 10 transactions in the body, so that is hash of all the values that will give Merkle root. So this is hash of block n minus 1. So this is the previous hash. So if you don't have any previous hash, then the previous hash will be 0. So if it is a Genesis block, then the previous hash will be 0. Then we have a nonce. So nonce will help in the mining, and every block will be having a difficulty target that is called cryptographic puzzle. So if any miner or any new node wants to add a new block into the blockchain, they need to solve this difficulty target. So if he is able to solve the difficulty target, then he can add the block into the blockchain network, and for that they will get the reward as a Bitcoin. So then some other fields we have balance of the wallet and the code and the storage and list of transactions. So here also hash of block n minus, this is the previous hash like this. So now we'll go to the next slide. So here we are going to discuss about what block header contains. A block is a container data structure that contains a series of transactions. Okay, so here there is a question: how many transactions we can perform, and what is the storage? So here is the slide. A block may contain more than 500 transactions on average. So here the block size around 1 MB to 8 MB. Okay, so now the header. What is the block header? Consists of previous block hash, mining statistics used to construct the block, and Merkle tree root. Okay, so now here we have a diagram. So like this is the previous hash. Okay, so we are going to discuss about previous block hash. Okay, so every block inherits from the previous block. So H1 is the this is the previous of H0, like that. Okay, so here we have a definition like a previous block hash. Every block inherits from the previous block. We use previous block hash to create the new block's hash. So which makes the tamper proof. So that is about the previous block hash. Okay, so now here we have a mining. Okay, so how to perform the mining? Okay, so here the mining is a mechanism that is done by the miners. The mechanism to generate the hash. So the mechanism needs to be complicated enough to make the blockchain tamper proof. Okay, so here in Bitcoin mining, so we have one formula. Okay, so here hash of HK minus 1. So that is concatenated with T, that is a timestamp, and concatenated with nonce. Okay, so here we need to find HK. We need to find this cryptographic solution puzzle by having previous hash, timestamp, and we need to find that nonce, for which nonce this equation will satisfies. Okay, so like that, that is mining. Okay, so here T is timestamp, N is nonce. Okay, so now Merkle tree root. So we have seen one field in the blockchain, Merkle tree root. So like we are storing the transactions in a body. Okay, so like you can say that, see the diagram, T1, T2, T3, T4. These are the transactions. Okay, so now here we are taking the hash of each transaction. So in the binary we have represented H00. Okay, so like that. So this is L2 hash, L1 hash. So the hash of entire thing will be the Merkle root. So hash of transactions, that is Merkle tree root. Okay, next slide we have that is transactions are organized as a Merkle tree. So if you change a transaction, you need to change all the subsequent block hash. So which makes a difficulty to modify the transaction in the blockchain network. Okay, so here we have one slide. You can see so how the transaction will looks like in the Bitcoin. So there is some public addresses. So we cannot know who is the user, where he is sending some cryptocurrencies. Okay, so like this, the transactions will be there in the blockchain, Bitcoin blockchain network. Okay, so here the summary. So in the blockchain summary, here we have two parts you need to understand. Block header, so which is helpful for the mining statistics, and body of the block. So that may consist of transaction. Okay. So now every time if you want to add any transaction, if you want to perform transaction, it should be updated in the all the blocks. Okay, so that the blocks in the blockchain network are consistent. Okay, so these properties we need to remember. Okay, so now I will show you one MetaMask how we are going to transfer the currencies from one place to the another place. Then we will go to the blockchain mining. Okay, so now I'm minimizing the screen so you can see my screen. Okay, so here you can see, so I have installed MetaMask wallet. So here MetaMask is one of the Ethereum wallet. Okay, so Ethereum is one of the blockchain platform. So if you want to develop the blockchain based applications, we have Ethereum, Hyperledger, many platforms are there. So here we have different blockchain networks, test networks, main Ethereum, Ropestan, Coven, Ringbait, and even we can connect to the local host. We can run the blockchain in our laptop. So all these things. Okay, so just to demonstrate how to transfer the cryptocurrencies. Okay, so now I'm going to use Ropestan test network. Okay, so here this is my public address. Here you can see a hexadecimal number. So this is the public address of the account, my account. Okay, so now in this account I have ethers. Okay, 2.99 ethers will be there. Okay, so now you can explore this option. Okay, so here you will get the details of my account. Okay, so now suppose I want to make a transactions. Now I want to transfer the cryptocurrencies. Okay, so one more account I have created. The name is Rishi. So here I have 0.99 ethers. So now I want to transfer from Shashi account. So I have copied the address. So this is the public address of Rishi. Okay, so you can see here. Okay, so now I want to send some currency. Okay, ethers I am sending. So here is the option. So I am placing this. So I have pasted the address of the receiver. Okay, so now here currently I have 2.99 ethers in my account, and how much I need to transfer. So I am trying to transfer 0.5 ethers. Okay, so and there again transaction fee. Okay, so in blockchain network, so if you want to perform any transactions, so there will be a transaction fees that will be paid in terms of gas in the Ethereum network. So gas is the fuel to the Ethereum network. Okay, so here we have different ethers. I am selecting the fast transaction, slow, average, and fast transaction fees. Okay, so now I'm going to give next. You can see that. So here gas fee will be calculated. That is, if you want to do the transaction, what will be the transaction charges? The transaction charges will be the gas fee. Okay, so I'm sending 0.5 for that transaction fee is this one. Okay, I am confirming the transaction. Okay, so you can see that the transaction is pending here. So it has to approved by the other nodes. Now I'm going to use Ropestan test network just for demonstration purpose. Okay, so you can see that. So previously I have deployed some contracts. So all the details we have stored here, that will be stored in the blockchain network. Okay, so the transaction is still pending. Okay, so let me, yes, it's sent. Okay, so now 0.5 ethers we have sent to some other account. You can see the details here. So how much amount, what is the gas limit, what is the gas price, everything. Okay, so in the detail, so there is an option V1 Etherscan. So you can click on this. Okay, you can see that. So whenever we are performing the transaction, that will be recorded in the blockchain network. So for that particular transaction, so this is the hash. So I have performed one transaction. For that, hash value is this. Then status is success. What is the block number? This is the block number. Okay, so here is the timestamp. When is the block is added? Okay, so from this account, I have sent to this account. What is the value? 0.5. So this is the transaction fees. So like that, every details we are going to store in the blockchain. So this we cannot modify this data. So now we can see the Rishi account. So I have made some transaction. You can see that. So here also deposit option is there, and we got the ethers, 0.5 ethers from that. Okay, so not only for transferring the cryptocurrencies, here we can deploy the smart contracts. Okay, so we can write the blockchain programs using Solidity or any other programming language. Then we can deploy into the this one Ethereum network or Hyperledger network. See here I have deployed previously, so that is contract deployments is possible. So that will be stored in the blockchain network. So this is about how to transfer the cryptocurrencies. Okay, so now let me explain more about blockchain. So like how the mining will happen. So that is mining. So here we have some slides. You can look into this slideshow from beginning. Okay, so now we will discuss about blockchain mining. So how the mining process will happen. So what are the things inside the blockchain mining? Okay, so now here we have a definition. What is mining? So actually mining is done by the miners in the Bitcoin network or blockchain network. So here blockchain mining refers to the activity which is performed by the miners on the network to get the new blocks added to the blockchain. So like whenever we are performing transaction, that is unconfirmed transaction. If you want to add that block, so we need to perform the blockchain mining. So who will perform the blockchain mining? So there are miners. So miners will perform the blockchain. They will solve that cryptographic puzzle. If it is successful, they will add the block into the blockchain. Okay, so we will see what are the steps in the blockchain mining. So we have definition like mining is the mechanism that allows the blockchain to be created securely and in a decentralized manner. So that is mining. So you can see this slide. So here we have some steps, blockchain mining process. So what are the steps in blockchain mining? Okay, so how to perform the blockchain mining? So here we have some steps. The first step is token dispatch. The token dispatch is nothing but whenever we are sending some cryptos or tokens from one wallet to the another wallet in the blockchain or Bitcoin network. So it should be, the transaction should be distributed or broadcasted. That is the one token dispatch. You can see that when a user tries to perform a transaction of some value through the network, so then cryptos will be dispatched. Okay, after that, after token dispatch, broadcasting. Okay, so the transaction will be sent to all the nodes in the blockchain network. So that is broadcasting of transaction. Transaction is added to the pool of unconfirmed transactions. Whenever we are sending the cryptocurrencies, that is unconfirmed, because in the normal scenario there is a banks. Okay, so banks will verify whether we have a sufficient balance to transfer. If you have insufficient funds, you cannot transfer. So here in the cryptocurrency, in the blockchain, who will verify that? Because there is no third parties involved in the blockchain. So how to do that? So there some validators will be required for that. So that is blockchain mining. Okay, so that is the transaction will be sent to all the nodes for the validation. So now selection of a transaction. Okay, so here the miner will select a unconfirmed transaction from the unconfirmed transaction pool. After that, you will create a block. So you will takes all the transaction, unconfirmed or pending transactions into the block, and he will tries to mine. He tries to mine is nothing but he tries to find the cryptographic puzzle. Okay, so there may be a cryptographic target value. For that, you need to find a solution. Okay, so with help of proof of work. So if he finds that solution, now we can add the block. So before that, he has to send. So the miner will find the solution for that cryptographic puzzle. So he will broadcast to other nodes. So other nodes will validate. So whether it's a valid solution or what. Okay, so like that mining will work. So let me demonstrate in detail. So how we are going to do the mining. So you see this slide. So here joining in a Bitcoin peer-to-peer network. Here we have one simple network. So there are nodes which are connected. Okay, so you can see this slide. Second slide. So joining in a how to joining in a Bitcoin network. Now there is a red circle. So this is the node that want to join with the Bitcoin network. So now what that particular node has to do? Okay, so now it will ask the address. Okay, so this is the seed node. Okay, so the new node will ask seed nodes about the address. So what are the addresses you have? You can give me so that I will connect like that. The seed node will be having the addresses of neighbors. So here it will get the addresses of the neighbors. So which gets the address list. Okay, so seed node will send the address list. Okay, so after that the new node will connect to the with help of the seed node. The particular new node will get the addresses, and with help of that addresses the new node will connect to the neighbor nodes. Okay, so now so this is the recent blockchain network. So just that the red node is added. Okay, so now the red node can perform the transaction. So now like a Bitcoin, one user has joined. Okay, so then it has to perform some transaction. Okay, so now the new node can perform the transactions, like they can send the Bitcoins, they can receive the Bitcoins. Okay, so now here we will see. So what is the procedure to send a Bitcoin? Okay, so now there is a scenario Als and Bob. Okay, so here Als wish to transfer the some Bitcoin to the Bob. Als can sign a transaction with the private key. Okay, so now here you can see this formula. So there is a if A wants to send Bitcoins to B, Bob. Okay, so now before that the public address of the B should be given to the Als. Then only she can send. Okay, so now there is a T transaction between A and B. Okay, so that transaction is signed by A. So that is digital signature. Okay, so sign with help of the private key of the Als, secret key of the Als. The transaction is signed. Okay, like that. Now see that after sending the transaction, now Als will send transaction, that is Bitcoin to the Bob, that will be spreaded or broadcasted across the blockchain network. So that is there is a transaction happened A to B, the Bitcoins 10 have been transferred. So that information will be broadcasted into the entire network. So now all the nodes has to validate. So whether it's a valid transaction or invalid transaction. So that is validate the transaction by other nodes. Now other nodes are responsible to validate the transactions. Okay, so now here other nodes also flood these transactions across the nodes. So that is the slide here. Okay, so now you can see that now here the node it will be again it's sending the same transaction to the node which is already earned. So it is I have already seen the transaction like that. Okay, so now you can see this slide transaction flooding in a Bitcoin network. So the transactions will be spreaded like this whenever we are performing. So all the transaction details will be stored. So you can see the slide A to B, the Bitcoins 10 is transferred, and C to D, the Bitcoins 20 is transferred. So like this, all the information will be stored in the blockchain up to date. Okay, so now here different nodes may have different transaction details. Okay, and accept the first transaction that you have heard. Okay, so that is very important. Okay, so now you can see that after performing the transaction is unconfirmed. So the Als sent some Bitcoins that is sent to the Bob, that is unconfirmed because miner has to approve that, other nodes has to validate that. Okay, so now how the miners will do that? Okay, so now mining in a Bitcoin network. So here every node is not a miner. So if you want, if you have particular resources, then it can be a mine. Otherwise, no need. Okay, so like that. Here, 3 nodes are miners. So miners, what they will do? Miners will collect the transaction flooded across the blockchain network. So miners collects all the transaction flooded across the network. Okay, so like that. So now here block generation puzzle. Okay, so how to generate the new block? So the new miners will generate a block. Okay, so he has to solve the puzzle. Okay, so what are the parameters in that? So previous hash we have seen one formula. H of k is equal to hash of h of k minus 1 concatenated with timestamp and nonce. So it has to satisfy that equation. Okay, so then nonce value you need to find. Miner has to find the nonce value. Okay, so like you can think that, so here some zeros are there. This is the difficulty target or cryptographic puzzle. In order to get this puzzle, which nonce value he has to use? Okay, so here the what miner will do, the miner will mine. Okay, so now he will randomly uses the different nonce so that the output should be the leading zeros like this. Like, so once he succeeds, then he can add. So this is he will try. So he has to run the algorithm many times. So this is called proof of work. Okay, so now the miner, in order to find the solution, so he has to spend so much hardware or computing resources in order to guess this value. So at what nonce value, the value we will solve the difficulty target, that is unknown. So that is done by the miners by using the computing resources. Now you can see that block generation. Okay, so those there may be a number of miners in the blockchain network. The miner who solves the puzzle first, he will add the block into the blockchain network. Okay, so now after the miner will find a new block that will be flooded into the, so you will send that transaction or broadcast that transaction into the other nodes in the blockchain network. So that is the flood the transaction with the new block included. Okay, so now block propagation. So once the particular miner will find the solution, so even multiple miners can mine a new block simultaneously or in a identical time. So there is a situation. What will happen if two miners will give the solution at the same time? Okay, so at that time, who will get the reward in the Bitcoin network? So in that case, we will consider that two miners will be known as orphan nodes. Okay, so based on the proof of work, who has executed, who has spent so much computing resources, they will get the reward in that case. Okay, so now one more question. So like where we need to add a new block. So in blockchain consists of more blocks or huge blocks. So where we need to add a new block. So the miner will mine a new block. After that, where you want to add. Okay, so for that there is a rule called longest chain. Okay, so here we need to add the longest chain. So longest chain is nothing but not the recent chain. So like the block, it will be having more number of transactions and more number of proof of work. More number of proof of work is nothing but the particular node is involved in validating more number of transactions. So that is which gives more proof of work. So we need to attach to the that block. For example, here we have block 8, 9, 10. We need to add a new block. So we don't know where we need to add. So that is based on the longest chain. So the node, it will be having maximum proof of work. There we need to add a new block. For example, in this scenario, block 8 will be having more proof of work. So they have connected block 11 into the block 8. So that is the longest chain rule in the Bitcoin network. Okay. So now there is one problem in the Bitcoin network, double spending problem. So what is mean by double spending problem? So in the normal bank scenarios, so bank will verify whether you have a sufficient balance in order to transfer the amount. Okay, so like that. So if you don't have the sufficient balance, you cannot make any transactions. In Bitcoin network, who will verify that? Now you can see that scenario. The ALS, she is having 50 Bitcoins. Now at a time, she will transfer the 50 Bitcoins to B as well as C. Okay, so this is an invalid transaction. How to identify this? Because there is no central entity in the blockchain. So who will validate this? So that is the question. So here in a centralized system, the bank prevents double spending problem. In blockchain, who will prevent? Okay, so here blockchain will records all the data. Okay, so the solution is the validators. Okay, so here every time if Als get some amount or bitcoins, if she sends the bitcoin, so all the transaction information will be updated in other nodes in the blockchain. So they will verify. So this thing is called validation. Okay, so the double spending problem can be avoided using this one proof of work and with help of consensus protocol and based on the validation. So we'll discuss in the validation in the upcoming slide. Okay, so here the answer is the double spending problem can be solved using this one validation process. Okay, so now one more important concept we have, like consensus. Okay, so what is the consensus protocols in the blockchain network? Okay, so here the consensus protocols are the systems we can say. So these are the agreement. Okay, so blockchain technology allows all the network participants or blockchain nodes to reach an agreement known as consensus. So like if in a blockchain network, if anything goes wrong, so we have to take the collective decision. Okay, so that is based on the consensus mechanisms. Okay, so if a blockchain, if you want to take any decision, we are going to use consensus mechanisms. Okay, so other definition, so this is a procedure to reach in a common agreement in a distributed or decentralized networks. Okay, so this consensus mechanism is very important for message passing systems. Okay, so now you can see that why consensus will be required. So if you are not using the consensus, what happens? So here mainly consensus are used to provide the reliability and fault tolerance in a blockchain network. So we need to provide the reliability as well as if any faults we need to avoid, that can be done using consensus protocol. Okay, so what will happen in a distributed or blockchain networks? So like there may be a crash fault, so a node suddenly crashes. Okay, suppose the blockchain node is unavailable or something will happen in between the communication. So now who will give the right solution for that? Suppose a part of the blockchain network will be disconnected. So that is network or partition fault. A network fault occurs when the network gets partitioned. At the time, who will give the validation, whether it's a valid or invalid transaction. Okay, so and some other faults will be like Byzantine fault. Okay, Byzantine is nothing but a particular node in a blockchain will behave maliciously. So in these cases, who will take responsible in the blockchain network? So the solution is consensus protocol will take the responsibility. Okay, so now what consensus protocol will do, which ensures the safety and liveness. Okay, so what is mean by safety? Here in the blockchain network, correct individuals must not agree on incorrect value. Okay, so nothing bad happened. And liveness, every correct value must be accepted eventually. Okay, something good eventually happens. Okay, so in order to ensure safety and liveness, we need a consensus. Okay, so then you can see that the objectives of consensus algorithm: coming to an agreement, collaboration, cooperation, equal rights to everyone in the blockchain network. And if you want to verify the transaction, that is mandatory participation will be required. So all these objectives will be done by consensus mechanisms. Okay, so now there is a Byzantine general problem. Okay, so here what is mean by Byzantine general problem? So here you consider the scenario. Okay, so in a army there may be a generals. Okay, so they want to attack on particular enemies. Okay, so here generals will be distributed among different direction. So each general will be having some soldiers and they are ready to attack the enemies. Okay, so before going to attack, so they need to exchange the messages about the situation. So whether we need to attack, otherwise we need to retreat. Okay, so now we can see this diagram. There are four generals. They are situated in different places. Okay, so now before starting the war, they are going to exchange the messages. Okay, so whether we need to attack. So like all others are giving attack. One major or one general is giving retreat because he is behaving maliciously. In a blockchain network, if particular node gives wrong information, what we have to do? So like that, because we cannot say that all networks will be truthful, all nodes will be truthful. Few nodes or few people will give the wrong information. Okay, so that is Byzantine general problem. Some nodes will behave maliciously in the blockchain network. We need to avoid that. That is the conclusion. Okay, so now for that we have a consensus protocol called BFT. So BFT is a Byzantine fault tolerance. Okay, so this is the feature of distributed network to reach consensus even some of the nodes in the network fail to respond or respond with incorrect information. So like in order to avoid Byzantine nodes, we have a algorithm called BFT that will take care of that faulty nodes. Next, we have one more consensus algorithm like proof of work. So the proof of work is a consensus algorithm we are going to use in Bitcoin network. So here proof of network is nothing but for the blockchain mining, the miner has to show the proof in order to add a new block. So here you can see the thing. So this is the central idea behind this algorithm is to solve a complex mathematical puzzle, and the miner has to give the solution for this. Okay, so this mathematical puzzle requires a lot of computational power. Thus, the node who solves the puzzle as soon as possible gets the mine the next block, like that. So in order to add a new block, so they have to show the proof of work. So proof of work is nothing but they need to solve the cryptographic puzzle. That is, then you will get the reward in terms of bitcoins for that. This is the proof of work. And proof of stake, this is also different consensus algorithm. So this is compared to proof of work, this is different. So here the miner is not going to use any computing resources. So here the proof of stake, here the blockchain nodes itself behaves as validators. So here what the blockchain nodes will do, so they will bet on that particular transaction and they will try to solve that the unconfirmed transactions. So for that they will get the reward like transaction fee, that is proof of stake. Okay, so here proof of work is nothing but they need to solve the cryptographic puzzle. Here the nodes are the validators, so they will validate the transactions and they will decide which is valid and which is invalid. So for that they will get the transaction fee. So for that they have to pay something. So the people who will be having a stake, they can earn the money in the Bitcoin network. That is proof of stake protocol. Okay, so now we have to understand the blockchain network is known as P2P network. Okay, so here you can see the structure of P2P network. Okay, so the blockchain is a peer-to-peer network working on the internet IP protocol. So a P2P network is a flat topology, so there is no centralized node. Okay, so here all the nodes equally provide and can consume the services. Okay, so which provides security, P2P networks. So now one more slide we have. So DLT, blockchain, sometimes we will call it as the DLT or distributed ledger technology. Why it is? Okay, so first of all we will understand what is meant by DLT. So distributed ledgers use independent computers to record, share and synchronize the transactions in the network. So here the transaction details are recorded in the multiple places at the same time, that is distributed ledger. So now blockchain is one of the distributed ledger. It will be having the properties. Okay, so now you can see that blockchain is the properties like programmable. So for blockchain technology, we can write the programs, that is smart contracts. Okay, so using different programming languages like Solidity, etc. Now here blockchain technology is secure because we are going to use the crypto primitives here. Then blockchains are immutable. So we are going to use the previous hash in order to connect between the nodes. So it is highly impossible to corrupt the data that is stored in the blockchain. So now blockchain is distributed as well as anonymous. So the users in the blockchain is anonymous. We are not revealing the details of the user in the blockchain technology. And time stamped. Whenever we are performing some transactions, that will be recorded with the time and date, everything. And unanimous. So like cooperation will be there. So if you want to take some decision, so there is a consensus protocols. So these are the properties of blockchain you need to understand. Okay, so now let me explain. So what are the different types of blockchains are there? So the different types of blockchains, like, so we have a public blockchain, private blockchain, federated or consortium blockchain. So mainly blockchains are classified into three types. Now what is meant by public blockchain? So public blockchain is nothing but permissionless blockchain. So here anyone can join into the network and they can perform the transaction. So the best example of public blockchain is Bitcoin and Ethereum. So these are the public blockchain networks. So next, private blockchain. So private blockchain is a permissioned blockchain. So only the known persons. So like individual organization or companies, they want to develop the applications, blockchain based applications. So they can make their own blockchain network and they can deploy. So like that is private blockchain. So the example for private blockchain networks like Hyperledger we have and Corda we have. And next, the federated or consortium blockchain network. So this is also permission blockchain. So here three or more organizations. A group of organization will involve in this blockchain and they will develop the applications. Okay, so the examples of federated or consortium blockchain like Quorum, Dragon, Chain. Okay, so you can see the differences. So we have three different blockchain networks like public, private, federated. Okay, so now you can see the differences from this slide. Okay, so first is access. So in the public blockchain, anyone can join. Okay, so here a private blockchain, single organization. In the federated, multiple selected organizations can join and they can develop the application. Okay, so next, participants. So here participants are permissionless and the users are anonymous in the Bitcoin. So that is public blockchain network. So in the private and federated, so only permission network it is, and known entities will be joined. Then security. So the consensus mechanisms will be used if anything goes wrong in the public blockchain network like Bitcoins. So the proof of work and proof of stake mechanisms will be used. So here private blockchain and federated blockchain. So pre-approved participants and voting multi-party consensus. Okay, so that will be used as a consensus in the private and federated blockchain. Now, what is the transaction speed? Okay, so in the public blockchain, the transaction speed is low because the participants will be more. Okay, so the transaction validations will take more time. So here, lighter and faster in case of private blockchain as well as federated blockchain. Okay, so now you need to know, so what are the blockchain platforms are there in order to develop the blockchain based applications. So these are the top 10 platforms, blockchain platforms in order to develop the blockchain based applications. So like we have Ethereum, Hyperledger, IBM blockchain, multi-chain, Hydra chain, Ripple, R3 Corda, Big Chain, Open Chain, IOTA. So these things you need to remember. Okay, so now we know that Ethereum. So Ethereum is one of the public blockchain. Okay, so Ethereum is one of the highly active and open source blockchain. And what are the key features of Ethereum? Here, open for public use, and this is based on proof of work. Okay, so and second we have Hyperledger. So this is also one of the recently developed blockchain. So which is based on the Linux Foundation. The objective is to build blockchain technologies across the different industries. So here Hyperledger can be used in use cases like finance, banking, IoT, supply chain, manufacturing, technology. Okay, so here you need to know, so where we can apply the blockchain. So that is blockchain use cases. Wherever transparency is required, wherever security is required, so in that fields we can deploy the blockchain technology. Okay, so like the commonly used use cases of blockchain in the financial sector, so digital identity, education sector, logistics, health sector, insurance sector, retail, agriculture, and land registrations. These are the major use cases of blockchain. Okay, so now we can see the slide. Okay, so why the blockchain technology is so popular? So like the government of India and across the world, they already initiated so many projects through blockchain. So for example, in Andhra Pradesh, so the already blockchain projects have been initiated by the government of India. So like blockchain database, cyber security applications, healthcare applications, land registry, vehicle registration. So similarly, you can see in other states also, like Assam, Delhi. Okay, so in Karnataka. So many places the blockchain is going to be deployed. So which offers transparency as well as security. Okay, so these are the use cases. Okay, so now why we want to learn the blockchain? So there is a huge case of blockchain developer in India as well as across the world. So there may be a number of opportunities. So if you learn the blockchain, so like a blockchain developer. Okay, so some other designations will be there. Okay, so blockchain is one of the interesting areas so where you can learn the things. Yes, that's it from my presentation. If you have any inquiries, you can ask me now.
Sir, thank you, sir. Thank you so much for your presentation.
Yes, sir.
Now we'll take some questions, sir. Meanwhile, I'll be posting the attendance link in the YouTube as well as in the this one. So I request all the participants, those who want to ask questions to the Seshadhar sir, to raise your hand so that I can unmute you and you can ask your question.
Yes, sir, sure.
Yes, sir. I have unmuted Krishna Rao garu. P. Krishna Rao, sir.
Yes,
I have
sir.
unmuted you, sir. You can unmute from your end and you can speak to the resource person, sir. Krishna Rao garu. Maybe no. Okay, Dr. S.A. Jamil. Sir, I have unmuted you, sir.
Thank you for your nice presentation and neat explanation, sir. I have a doubt that what are the drawbacks of Bitcoin and blockchain, and how it can be overcome?
Okay, so the drawbacks of the Bitcoin is it? Hello. Okay, so like in Bitcoin, we have some regulation issues. So like, so even the people, they will spend the black money in the Bitcoin. So that is untraceable. So that is also one of the disadvantages. So for that, some legal agreements they are developing across the world. Okay, so few disadvantages are there in the Bitcoin. So that can be overcome in the future days. So in the blockchain technology, so the disadvantages is like, so in terms of storage, okay, so on the transaction time, it will take more time. So we cannot apply blockchain everywhere where we want. So the concept is like, so wherever security is required, transparency is required, so there you can use the blockchain. So in other aspects, so more features are there in blockchain.
Okay, sir. Next question from Saujanya, madam.
Yes.
Madam, I have unmuted you. So you can unmute from your end and you can speak. Okay. Maybe madam is not there, sir.
Sir?
Hello,
yes. Is it audible?
Yes.
Yes. Yes. No.
Sir, it's a very nice presentation, sir. As you said that there are some particular resources to become a miner. May I know what are those particular resources, sir?
Yeah, ma'am, you should have some computing resources like, so in single laptop or a desktop system, so we cannot download the entire blockchain. So if you want to the blockchain miner, we want to download the so many blocks. We need a storage space as well as the internet connectivity. So in order to solve that puzzle, so like we should have some servers in case of Bitcoin. So if you want to give the solve the cryptographic puzzle, like if you want to give the solution to the target value, so we should download the blockchain, that public blockchain network like Bitcoin, so which requires huge storage as well as which consumes the bandwidth.
Okay, sir.
Okay, thank you, sir.
You are unmuted, sir. So you can ask your question. Please unmute from your end, sir. Maybe no.
Hello.
Yes, sir.
Yes,
Hello.
yeah, sir. It's
Audible, sir.
Yes.
Hello.
Hello.
I am Kopil Sanbusi from CIET Engineering College in Narsapeta.
Yes, sir. Yes, sir. Please.
How to implement blockchain in educational side and also agriculture side, sir?
So blockchain in agriculture, is it?
And education also.
Yes, sir. So for that, in what you want to do in the agriculture or in educational sector. So like Government of India already started some few startup projects. So like for example, you can take educational. Educational purpose means, for example, in order to store the certificates in the blockchain. So for that, we need to write the smart contracts. Okay, so their smart contract is nothing but a computer protocol. So based on that, we are writing some agreement or rules that can be deployed in the blockchain. So according to your smart contract, the blockchain will behave.
Okay, sir.
Yes. Yes.
Very nice today's section, sir. Very nice, sir. I learn valuable things from you.
Thank you, sir. Thank you so much.
Very nice presentation, sir. Thank you, sir.
Yes, sir. Thank you very much.
The next one is someone from Annai College.
Yes,
sir, I have unmuted you, sir. You can speak. Someone from Annai College.
Hello.
Yes, sir. Sure.
Hello.
Did you
Hello.
able to hear me, sir?
So maybe your voice is not audible. So next, some Suresh. Suresh, sir, I have unmuted you.
Okay. Hello.
Yes, sir. It's audible.
Very good presentation, sir. Actually, my doubt is the same thing with the previous professor has asked from
Okay.
it was answered. Thank you for
Rest of the people, please mute yourself. Sir, next question. Sir, next question is from Ravi Patel, sir.
Yes, sir, sure. Let them ask.
Ravi, sir, you can speak now.
Yes, sir. Audible?
Yes,
Yes,
sir.
sir. Yeah.
Is it audible, sir?
Yes, sir. It's
Okay, sir. My question is that, sir, in blockchain, if you want to pursue your career in a blockchain technology, what prerequisites knowledge is required for blockchain technology?
Sir, yes, sir. So, like, if you want to, so you need some programming stuff. So, like Solidity programming, we are going to use in Ethereum. So, Solidity programming, the syntax is almost similar to C++ and Java. So, that we can use in order to write the smart contracts. So, in Hyperledger, so you can use the Python and Go language. So, that is your choice. So, that you can take the programming language, any language, and you can develop the application. Okay, so after that, you need to have, if you want to develop the client side or server side application, you should have some this one web technologies like that. In the blockchain, in entirely, if you want to learn the blockchain, we need to download some blockchain networks like Ganache. So there we can work.
Okay, sir. Next, Pramod, sir. We are unmuting you. You can speak, sir. Pramod, sir. You can speak now.
Sir, good
Yes.
afternoon, sir.
Good
Hello.
afternoon. Yes, sir. Good afternoon.
Sir, my question is in our daily life, we in our India also, we are going to encourage in a digital platform type of transactions like Phone Pay, Google Pay, Paytm, like that, sir.
Yes, sir.
So, more number of users are going to participate a number of transactions in Phone Pay, Paytm, like that. So.
Yes, sir.
So how many number of transactions can be saved in one block, sir?
Sir, that average number of transactions I said, so like only 500 transactions in each block. So that is storage is still issue in the blockchain technology. So to overcome that storage issues, so the cloud has introduced blockchain as a service. So we are going to use cloud. So there also we can store the transactions. So
Okay.
yeah, blockchain as a service is there right now.
Okay.
Yes, sir.
Okay, sir. Thank you. Thank you.
The next question is from Mangavani, madam. Madam, you are unmuted now.
Good afternoon, sir.
Good afternoon, ma'am.
Sir, how can we detect the double spending problem, sir?
So double spending problem, like, so every block will be having a details. So where they got the bitcoins and where they are sending. Suppose if any bitcoin is credited to your account, so that transaction will be reflected in all other blocks in the network. So whenever if you want to transfer that, again the transaction will be circulated into the entire blockchain. So there may be a validators. So they will check whether it's valid or invalid.
So the invalid transaction will be cancelled, sir?
Yeah, ma'am. We cannot make the transaction. So
Okay.
if you don't have the sufficient.
Thank you so much, sir. Your session was very informative.
Yeah, ma'am. Thank you so much.
Sir, next question is from G. Prasad, sir.
Yes.
Prasad, sir, you are unmuted now.
Yeah. Yeah. Good afternoon, sir.
Good afternoon, sir.
Thank you for your session, and I would like to know whether could you please suggest any eminent institutions that provides full level certificate course with real-time practices, hand-on practices through online.
Okay, so okay, so many courses are there, sir, in online, like in Coursera, so Udemy. So they're giving so many courses. So in certification course like Edureka, so they're giving some projects, even capstone projects. So you can do the certification from there, Edureka. So the site is.
Thank you, sir. I will appreciate if you add such resources in your presentation.
Sir, please, your question is not clear, sir. Can you ask me once?
If you add this particular links in your presentation at the end,
Yes, sir.
it will
I
be,
will
it will
share
be
the
helpful.
links. Sure, sir. I will share the PPTs and the link.
Thank you. Thank you so much, sir.
Sure.
Very nice.
Next person is Shweta ma'am. We are unmuting you. Shweta ma'am.
Okay, sir. Hello. Hello.
Yeah. Yes, ma'am.
Good afternoon, sir.
Good afternoon, ma'am.
Sir, this is Shweta from KSRM Engineering College, Kadapa, sir.
Yes, ma'am.
Sir, would you please tell the differences between confirmed transaction and unconfirmed transaction, sir?
Yes, ma'am. So here, whenever you are sending some Bitcoin to others, so that is not validated by other
మనం
nodes.
కోసేద్దాంలే.
So other nodes means the validators, other nodes are validators. So they have to see the transaction details. So whether the particular sender is having sufficient balance. So after mining, uh, the other nodes will be confirmed. Okay, so that is a confirmed transaction.
Okay, sir. Okay, sir. Thank you, sir.
Yes, ma'am.
Okay.
Next, 1 minute, sir. I'll unmute you. Pavan Kumar, sir. Sir, you can speak now. Pavan Kumar, sir. Okay, you can speak now, sir. So maybe not available. So
Good afternoon, sir.
yes,
Yeah,
sir.
good afternoon, sir.
I'm very much thankful for your valuable presentation.
Thank you,
So
sir.
my question is that how this particular Bitcoin is related to agriculture? You have told that it is one of the uses of Bitcoin, right?
No, sir. That Bitcoin is just cryptocurrency. So I said about the blockchain. So like a blockchain technology, we can use it for the agriculture. So like that technology behind Bitcoin or any cryptocurrency is blockchain. Okay, so
Yeah, how this particular blockchain is related to this particular agriculture?
yes, sir. So in a blockchain, uh, in order to avoid the intermediaries, so in the agriculture, you can take the agriculture use cases. So like, if you want, if farmers has to sell something, so like there may be a intermediaries. So it's like a supply chain, sir. So whenever the marketplace will be there, so that could be placed in the supply chain. That will be helpful. So farmers cannot do that things. So some others will take the initiative. So like government, so they can develop the application, blockchain based application for the agriculture. So like tracking the this one agriculture things by the government.
Yeah, one of our Telangana government is imposing one new scheme.
Yes, sir.
To which what is a related thing that we need to make use of in our field. So how this particular crop will be related to this particular blockchain? So which
Sir,
crop we must make use of? How this particular farmers will get this particular idea?
yes, sir. So here the blockchain will be there. So here blockchain, that is a decentralized network. So what the people will do? So like you can take the agencies like our government people. So they will keep the information of the crops. So whatever crop it is, so from starting to the ending, so they'll keep the things up to the market. So based on that, we can government can fix the price. So yeah, there is no intermediaries like brokers will be there. So that is
Okay.
the plan.
Okay. So thank you, sir. Thank you for your valuable seminar. It
Yes.
would be better if you share your slides and
Sure,
through
sir.
link.
Yeah, sir. I will share the slides
Yeah,
to
thank you.
Kiran, sir. He will share
Yes, sir.
everything. Yeah.
Sir, next one is Dr. Nirvikar.
Yes.
Sir,
Yes.
I am unmuting you, sir. Hello.
Yes.
Nirvikar, sir, you are unmuted now. So maybe he is not there, sir. Next one is Mayuri, ma'am. Mayuri, ma'am. One minute, sir.
Hello,
Hello, ma'am. Yes.
sir, it's Mayuri from Pune.
Yes.
Sir, I'm studying blockchain for my research. You just explained difference between confirm and unconfirmed transaction. And in your session, you told that unconfirmed transactions are stored in the pool of transaction.
Yes, ma'am.
So where that pool of transaction is stored in blockchain? Is it on a local machine or where is it stored?
No, ma'am. So that is, so once the transaction is initiated, for example, so A is sending some bitcoins to the B, so the transaction is initiated and that will be broadcasted. So that transaction has to collected by the miner. So miner should have some storage space. So he will collect all the transaction into a single block. So miner will do that.
Okay, means at minus node that pool of there is space for storing pool of transaction.
Yes, ma'am, sure.
Okay, so thank you for your nice session.
The next one is Mitla K. Hello. Hello.
Hello.
Yes, sir. You can speak now.
Sir, this is K.N. Rao from Nasrapat Engineering College Autonomous.
Yes, sir. Please, sir.
My question is in cryptocurrency.
Yes, sir.
Is there any organization which give the that means is there any organization which give the support for the cryptocurrency just like RBI give the support for our currency in India?
No, sir. So nothing like that. There is no central entity, or it is not controlled by any agency or any individual. So like that, the network is created.
Is there any chance for fluctuations in the currency rate, sir? Just like stock market or?
Yes, sir. But what the market value is 2020, so the demand for bitcoins will be increased. The fluctuations will be there, sir, that we cannot predict cryptocurrencies.
Sir, can you explain what are the different types of things that may fluctuate the bit currency?
So, like so based on the number of users who are involving the activities like transactions. For example, I'm very interested in the Ethereum, Ethers. So I don't want to purchase Bitcoin. So I will prefer my friends and others to purchase Ethers instead of the Bitcoin. So obviously, the users will be increased in the Ethereum or Ethers. So Bitcoin value will be decreased. So that we cannot estimate.